Hello, class. My name is Mr. Andrews. These are my assistants, Liam and Catherine, and today I'll be teaching you how to collect data. Some of you have probably been wondering, what is a sample? A sample is a subset of the population, and ideally, the sample is representative of the population, but that depends on how you get your sample.
That's so true. There are multiple ways to do this. Simple random samples, stratified random samples, cluster samples, and systematic random samples are peak and mock all the other samples methods. In a simple random sample, involves all random chance getting selected and randomly getting picked. In a stratified sample, the population splits into groups, and simple random sample will take each group. In a cluster sample, the population split into clusters, and cluster sample served, and the cluster served as the sample. A systematic random sample, intervals are chosen for the sample at random intervals. For example, per chance you could pick every 6th or 7th interval in a sample.
Bad sampling methods include voluntary response sampling, meaning respondents choose to be part of the sample, and convenience sampling, where selection is based on availability. Voluntary and convenience sampling both have high bias, meaning that certain responses are systematically favored over others.
There are three types of bias. Undercoverage bias happens when part of the population has a lower chance of being sampled. Non-response bias happens when individuals in the sample refuse to participate. And response bias happens when respondents give false answers, usually because of a perception that certain claims or answers are expected.
There are also two types of studies, observational studies and experiments. Observational studies observe and measure data, but do not involve influence the results, cannot be used to infer causation. Observational study must focus solely on random sample. So you want to generalize the findings to a population as a whole. Experiments do influence the results by subjecting different groups to different treatments, demonstrating a cause and effect relationship, allowing for inference about causation when random assignment is found.
There are different methods for setting up an experiment. In a single-blind experiment, the subjects are not aware if the treatment is real or a placebo. In a double-blind experiment, the subjects are still not aware if they're receiving a real treatment, but the researchers don't know which treatment they're giving either. In an experiment with a completely randomized design, the individuals are assigned their treatment by random processes such as random number generator, coin flip, dice roll, and the like. In a completely randomized block design, the sample is split into groups called blocks based on shared characteristics called blocking variables, and then are randomly assigned their treatments. Finally, a matched pairs design divides the sample into blocks or pairs, and then each pair receives both treatments to see if there's a difference.
Yeah, cool. Now let's do a free response question, sometimes abbreviated as an FRQ. People with acrophobia, fear of heights, sometimes enroll in therapy to help them overcome this fear. Typically, 7 or 8 therapy sessions are needed before improvement is noticed. A study was conducted to determine whether the drug D-cycloserine, used in combination with fewer therapy sessions, would help people with acrophobia overcome this fear. Each of 27 people who participated in this study received a pill before each of 2 therapy sessions. 17 of the 27 people were randomly assigned to receive D-cycloserine pill, and the remaining 10 people received a placebo. After the 2 therapy sessions, none of the 27 people received additional pills or therapy. 3 months after the administration of the pills in the 2 therapy sessions, each of the 27 people was evaluated to see if he or she had improved. Question A. Was this study an experiment or an observational study? Provide an explanation to support your answer. This is, of course, a very clear-cut example of an experiment. There is a treatment group that receives the treatment, which is the pill, and there is a control group which receives the placebo. Question B. When the data were analyzed, the D-cycloserine group showed statistically significantly more improvement than the placebo group did. Based on the result, would the researchers be justified in concluding that the D-cycloserine pill in 2 therapy sessions are as beneficial as 8 therapy sessions without the pill? Justify your answer. No, that would be a very silly mistake to make, because the control group only received 2 therapy sessions, not 8, so there's not a basis for comparison between the pill and 2 therapy sessions and no pill and 8 therapy sessions. Now alas, question C. A newspaper article that summarized the results of this study did not explain how it was determined which people received D-cycloserine and which received the placebo. Suppose the researchers allowed the therapist to choose which people received D-cycloserine and which received the placebo, and randomization was not used. Explain why such a method of assignment might lead to an incorrect conclusion. Well, some possible problems with this could be voluntary response sampling or convenience sampling, but also the results wouldn't be truly random, meaning that they couldn't be generalized to the population as a whole.